Hello class 7 students, welcome everyone. So today we are going to discuss from activity 15.7 of the chapter light. Okay. Yesterday in the last video we have discussed about real image and virtual image, right? What do you mean by real image? An image which can be obtained on the screen is called real image, and what do you mean by virtual image? The image which cannot be obtained on the screen is called virtual image. Okay. Acha. So activity 15.7. Okay, look in your book in page number 180. So as you have got that there are two types of spherical mirrors. One is concave mirror, and the other is convex. Okay, one is concave and the other is convex. Okay, so activity 15.7 is based on concave mirror. So fix a concave mirror on a stand and place it on a table. Okay, figure 15.15, as you can see over here. This is a stand. This is a stand to fix concave mirror. Okay. Paste a piece of white paper on a cardboard sheet, say about 15 by 10 centimeter. Okay, as you can see over here, on a cardboard sheet, what is pasted? White paper, fully white. Okay, white paper is pasted. So this will act as a screen. This will act as what? A screen. Okay. Keep a lighted candle on the table at a distance of about 50 centimeter from the mirror. You have to keep a candle, lighted candle, okay, on the table at a distance of about 50 centimeter from the mirror. Okay, this one. This is the lighted candle, as you can see, which is at a distance of 50 centimeter from the mirror. Try to obtain the image of the flame on the screen. Okay, you have to try to obtain the image on the screen only. On this screen only you have to try to get the image of this flame. Okay. For this you have to move the screen till a sharp image of the flame is obtained. As you can see over here, a sharp image is obtained, right? So make sure that the screen does not obstruct the light from the candle falling on the mirror. Now if you get a sharp image of the object, when you will get the sharp image of the object, when you will get the sharp image of this object, what is the object? Candle flame. Where you will get the sharp image of the object candle flame? You will get it on the screen, just like this. Okay. So this is the object. This is the screen. Okay, where you will get in the screen, what you will get? On the screen you will get the image. As you can see, this is the image of the flame. This is the image of the flame, right? So, is this image real or virtual? Is it of the same size as the flame? What you can say? This image is real or virtual? As you can see the image, it is inverted, right? It is what? Inverted. This, you can see the pointed flame. The pointed flame is at the bottom part. It is at the bottom part, the pointed one. This is the pointed region of the flame, right? It is at the bottom part. So what can you say? The image is inverted. Okay, image is what? Inverted. And since this image is obtained on the screen, such images are called as what? Real images. Such images are called what? Real images. Okay. Now move the candle towards the mirror and place it at different distances from it. In each case, try to obtain the image on the screen. Record your observation in table 15.1. Is it possible to obtain the image on the screen when the candle is too close to the mirror? Figure 15.16. Question mark is given to you. That means you have to see on table 15.1 what is given to you. Image formed by a concave mirror for object placed at different distances from it. In the first case, the distance of the object, that is candle, from the mirror was at a distance of 50 centimeter, right? It was at a distance of 50 centimeter. What was the size of the object? The size of the image. smaller than the object or larger than the object? It was larger. For 50 centimeter, the size of the image was larger than the object. Okay, as you can see from here again, the size of the image is what? Larger than the object. As you can see, larger than the object. The size of this image is what? Larger than this object. So you have to write over here what? You can use a pencil to write. You can write here larger, okay, than the object. Okay, in the second column of first row, 50 centimeter. Next, character of the image. The character of the image is inverted or erect. What is it? As I have mentioned already, it was inverted. Okay. Next, real image or virtual image? It was real image. Okay. You have to write it in your book. Next, when the object is brought, say, to a distance of 40 centimeter from the mirror, that means the object was brought near to the mirror. Okay, the distance between the mirror and the object now is 40 centimeter. It is brought close. So what can you say about the image? Smaller than the object or larger than the object? You have to write again larger than the object, as you can see from here. When the candle flame was brought near to the mirror, as you can see, the image obtained here is larger. Again it is inverted. Okay, and this image is again what? Real image. Clear? Are you getting it? The size of the image is larger than the object, as you can see. See the size of the flame over here. The size of the flame is larger over here, right? And the size of the flame is smaller over here. So which one is larger? Size of the image is larger. Are you getting it? That is why I have written over here what? Larger. And as you can see, this again, this image is inverted. Image is what? Inverted. And since the image is obtained on the screen, what type of image is this? It is real image. Are you getting it? So what you will write over the second column, second row? Larger, when it was brought near to a distance of about 40 centimeter. Character of the image. Character of the image is real or inverted or erect? It is inverted again. Okay, it is what? Inverted again. Next, real or virtual? It is real again. Are you getting it? It is real. Clear? Okay. Next, when it is brought, when the object was brought near to a distance of about 30 centimeter again, what can you say? What can you say about the size of the image? Larger than the object or smaller than the object? Again it is larger. The picture is not given, I think, in the book, but you have to write here larger only. Okay, you have to write here larger only. No, picture is not given over here. Okay, it was larger. Okay, next, character of the image is inverted or erect? It is again inverted. It is again what? Inverted. Real or virtual? It is real again. Okay. Next, when it was brought to a distance of about 20 centimeter, then what happened? It got enlarged. That means highly enlarged. Means larger, more larger than the object. Okay, enlarged. Okay, enlarged. And this time the character of the image is got erect. And here the image is virtual. Image is what? Virtual. Now you can see over here this figure, this picture. Figure 15.16. Virtual image formed by a concave mirror. As you can see over here, the candle is brought very close to the mirror. Concave mirror only. The candle is brought very close to the concave mirror, but there is no image shown on the screen. Right? The image is only formed on the mirror. Okay? This images cannot be brought to the screen. So such images are called as virtual image. Such images are called, which cannot be obtained on the screen, are called as virtual image. It is called as virtual image. Okay, and since, as you can see over this mirror only, the size of the image is very large. Okay, the size of the image is very large than that of the object. That is why it got enlarged. We have written over here what? Enlarged. Okay, and also, as you can see, the tip of the flame is pointed upwards, that is why it is what? Erect image, not inverted. This time you will get what? Erect image when it is brought very close to each other. Okay, so see, we see that the image formed by a concave mirror can be smaller or larger in size than the object. Yes, we have seen just now that the images formed by a concave mirror can be smaller than the object or can be larger than the object. Also, the image may be real or virtual. It can be real also or it can be virtual also. Okay, these two things are left. Yes, for 10 centimeter also it is brought very near to each other, right? The object is brought very close to the mirror, concave mirror. So the size of the image will be what? Again it will be enlarged. Again it will be what? Enlarged. If it is brought near very close to each other. Character of the image is what? Erect or inverted? It will be erect again. Okay. Next, real or virtual? Again it will be virtual. Okay. And for the last one, when the object is brought at a distance of 5 centimeter near to the mirror, very close this time again. So what will be the size of the image? Again it will be enlarged. Again it will be enlarged. Okay. Character of the image, again it will be erect. And real or virtual, it will be again virtual. Okay. Clear? So the size of the image can be smaller than the object or it can be larger than the object, and the image can be real or virtual in nature. Clear? But what are the, you can say, what are the uses? What are the uses of concave mirrors? Okay, in the last paragraph of this page, page number 181, we'll discuss about some of the uses of concave mirrors. Okay. Okay, let's start from the last paragraph only. Next, yes, concave mirrors, the uses, you see, concave mirrors are used for many purposes. Okay, you might have seen doctors using concave mirrors for examining eyes, ears, nose and throat. Basically, doctors uses concave mirrors to produce what? Parallel beam of light. To produce parallel beam of light for examining the body parts like, say, eyes, ears, nose and throat. Next one is by dentists. Concave mirrors are also used by dentists, basically, to see the large images of the teeth of the patients. Basically, in the table only you have seen, right? In the previous table only you have seen that for most of the cases you got the image to be larger than the object, right? You got the image to be larger than the object. So basically, dentists uses concave mirrors to see the large images of the teeth of the patients. Okay, when a tooth is close to a concave mirror, then an enlarged image of the tooth can be seen in the concave mirror. So due to this, it becomes easier to locate the defect in the tooth by the dentists. Okay, that is why dentists uses concave mirrors to see the teeth and all. Okay, because it produces enlarged image. Okay, next, yes, concave mirrors are used in reflectors, are used as reflectors basically to see the, not to see, basically reflectors in torches. Okay, you have seen torch and all. Concave mirrors are used as reflectors in torch headlights of vehicles, like say in cars it got used, it has a use in scooters, in buses, trucks. Okay, and in train engines also concave mirrors are only used. Okay, are you getting it? And it produces what? Strong and straight beam of light. Basically, when a lighted bulb is placed at the focus of a concave reflector, what will happen? It produces powerful beam of parallel light rays, and this helps us to see things to a considerable distance in the dark night. Are you getting it? So remember that concave mirrors are used as reflectors of torches, headlights of cars, scooters. Okay. Yes, these two paragraphs, these two pictures are given to you. Okay, where the dentist uses concave mirror to see the enlarged image of the teeth. And here, in case of reflectors. Concave mirrors are used as reflectors in torches in wall. Okay, reflector as a of a torch. Clear? So Bujo observed his image in the shiny surface of the bell on his new bicycle. He found that his image was erect and smaller in size. He wondered if the bell is also a kind of spherical mirror. Can you recognize the type of the mirror? See, if you have seen the cycle bell of yours, if there is cycle with you, you must have seen cycle bell, right? So if you just stand in front of the shining surface of the cycle bell, it will act like a mirror because you can able to see yourself in it. Okay, so what type of spherical mirror is the cycle bell? You can say it is convex. It is what? Convex in shape. Okay, note that the reflecting surface of the bell is what? Convex. Are you getting it? It is convex in shape. Now there is again an activity 15.8. Repeat activity 15.7 now with a convex mirror in place of a concave mirror. Record your observations in table similar to table 15.1. Okay, you have to use the same setup. You have to use the same setup. You have to use the candle. You have to use the screen. You have to use the stand, but in the stand you have to place convex mirror. Okay, you have to place what? Convex mirror. Okay, and for each of the distances you have to note down the observation. That means when the convex mirror is placed at a distance of 50 centimeter from the object, from the candle flame, what will be the observation in this case? You have to note it down. What type of image you will get? Either it will be inverted erect or it will be real or virtual. What you will get? You have to note down for everything. Okay. But one thing you should remember for convex mirror is that whether an object is placed at a distance or whether the object is close to the convex mirror always forms virtual image. It always forms virtual image. Always. Convex mirror always forms what? Virtual image. The images cannot be obtained on the screen, as you can see over here. The image is not obtained on the screen. It was obtained only on the mirror. Okay, it forms always virtual image. Also the image is erect. Every time you will get erect image. Whether you will place the object close to the mirror or far from the mirror, you will get only erect image. Okay, also you will get smaller image. Okay, smaller than the object. Okay, the size of the images is always smaller than the object. Whether you place the object too close to the mirror or far apart from the mirror, you will get virtual image, erect image, and smaller than the object. So in each of the cases, you have to note what? Smaller. Okay, here you have to note erect, and lastly, here you have to note virtual. Okay. Are you getting it? For convex mirror, only for convex mirror. Okay, as you can see from this figure, only in this figure 15.19 only, this image is cannot be obtained on the screen, so it is virtual image. This image is say upright only, that is the flame is at the top position, the tip of the flame is at the top position, that is why it is erect image, and this image is smaller than the object. As you can see the size, you can compare the size, that is why it is smaller than the object. Okay, so this is the observation in case of a convex mirror. Remember, whenever the object is placed at a distance or close or farther apart from the convex mirror, okay, the convex mirror always forms virtual image, erect image, and is smaller than the object. Okay, the size of the image is smaller than the object. Clear? So could you get a real image at any distance of the object from the convex mirror? No, you will get only virtual image. Did you get an image larger in size than the object? No, we will get the image which is smaller than the object. So can you now recognize the mirrors used as side mirrors in automobiles? If you have automobiles in your home, okay, if you have automobiles in your home, like say cars, scooters, buses, trucks, okay, if you have seen these things, the side mirrors if you have seen, then what is the size of the image when the objects are falling on the mirror? What is the size when the light is falling on the mirror from the object? What is the size of the image you will get? What is the size of the image of cars, scooters, buses and all behind the side mirrors? What is it? It is smaller than the object. So convex mirrors are used as rear view mirrors or side view mirrors in vehicles, buses, trucks and all the vehicles to see the traffic at the back side of the road. That is why it is used, to see the traffic at the back side of the road. Okay, so these are convex mirrors actually. Okay. Convex mirrors can form images of objects spread over a large area. Are you getting it? It forms, we can say, it gives a wider field of view. It gives a wider field of view. Okay. You see, plane mirror also gives virtual image, but the size of the image is the same as that of the object. Are you getting it? It does not give wider field of view. Plane mirror do not give wider field of view, but convex mirror gives wider field of view. That is why it is better to use a convex mirror as a rear view mirror than a plane mirror. Okay, we will not use plane mirror in the side view mirrors of the vehicles. We'll use what? Convex mirrors, because it gives wider field of view. If the field is wider, then the size of the object is smaller, then the size of the image is smaller. So you will be able to see a wide range of view in case of a convex mirror. Okay, so these help the drivers to see the traffic behind them. That is why convex mirrors are used in case of automobiles as a rear view mirrors. Okay, so yes, we have completed the convex and concave mirrors and all the image formations, the nature of the images. Remember that in case of a concave mirror, most of the cases you will get what? The size to be larger than the object, but the nature of the images can be real also or virtual also. And yes, real also or virtual also, and inverted also and erect also. Okay, but in case of a convex mirror, the size of the image is always smaller than the size of the object, and the nature of image is virtual and erect. Okay, so that's all for today. Thank you and have a nice day. We'll continue the chapter in the next day.